Hi everyone, welcome to my channel Pure Biology, and today I come with the continuing video of the LOTKA VOLTERRA model, and I have explained the first part in my previous video, so you just check out that one, and this is the second part of the LOTKA VOLTERRA model. So here I will try to explain about this model or how the predictions come by analyzing of these two graphs, okay? And let's continue. What is saying that this LV model, this describes the outcome of the competition, which is described by this model. This model generally describes the outcome of competition. That means outcome of competition meaning that if there are two species, 1 and 2, so which one is affected by the which species, this is actually the outcome. At last we will just predict that which species is hampered by the which one. This is the prediction. And here the values for, if the values for each equation are known, so then we can calculate or we can predict the potential outcome of a competition. Clear? And to understand these predictions, there are two graphs that is very briefly or roughly drawn here, and we have to understand how this model predicted the outcome. Okay, how this model predicts the outcome of the species by this graph. This graph is called the state space graph. This is called the state space graphs, and you can see here two straight lines present in both the graphs, and this straight line is known as the zero isocline. Okay, this is called the zero isocline, and where d and dt is 0. What is the meaning of d and dt is 0? d and dt is 0 is that the population of the species, the population size does not change. Okay, this line is called the zero isocline line, and this shows that this space or this is the region where no population size is changed. This is called the zero isocline. Okay, and if any points that remained below this zero isocline line, that means here the number of individuals of a particular species that become increasing, and if any points are there, that means just above the zero isocline, that means here the species 1 individuals that become decreasing. Clear? Same thing is here, that if there are the points, these are the points, you can see that these are the points. Okay, if any points just remain below this line, that means here the individuals number increasing, and if points are there, so that means the number of individual decreasing. Clear? These are the points. Okay, these are the points. So here n1 and n2 both are remain here, and n1 is present in the x-axis and n2 is present on the y-axis. Okay, so that means the species 1 is plotted on this graph according to the x-axis, and species 2 plotted according to the y-axis. Clear? And there is the outcome which we calculate. That okay, first of all, what are this k1 and k1 by d alpha 1 and 2. So this point is k1 and this point is k1 by alpha 1 2, 1 for species 1, 2 for species 2, and here this point is k2 and this point is k2 by alpha 2 1, and this line is dn2 by dt is 0. That means no individual size or population size changed here, and there is the line, this is dn, I have written here dn1 by dt, this is 0. That means no population size is changed here. Now the calculation start. What is this calculation? That means we can map out the regions increase and decrease for the species 1 and 2. So if dn1 dt is 0, so that means r1 n1, okay, without seeing the first part of this model you cannot understand this calculation, because this is linked with the first part. Okay, now I don't explain about this equation, how it is drawing from this logistic model or logistic equation. I here cannot explain it. Okay, so here what is saying that dn1 by dt is 0. That means this one is 0. So here this r1 and n1, this is going to this side, because the sign is multiplication, you can see here. That means this is going to this side, and that means here r1 n1, sorry, r1 is 0, n1 is also 0. Clear? And so that means k1 minus n1 minus alpha 1 2, sorry, 1 and 2 n2, that becomes 0. Okay, so now we can write this equation in such way: k1 minus alpha 1 2 n2 the equals to n1s. Okay, n1, we just sending this n1 in the right hand side. So now we can write in such a way: when n1 is 0, then you can write that k1 equals to alpha 1 2 n2. Okay, now what is the value of n2 now? n2 is that now k1 by alpha 1 and 2. So now if n2's value becomes 0, so that means n1 is equal to k1. Okay, when the n1 is 0, so we can calculate this one. n2 is k1 by alpha 1 and 2. But suppose in that situation, okay, I have to write this one, then you can understand. 1 2 n2 equals to n1. So if n2 is 0, okay, n2 is 0, that means this becomes 0, so that you can write that k1 equals to n1. Okay, again I repeat how this is occurred. Okay, suppose r1 and n1 is 0. How? r1 n1, if dn1 by dt equals to 0, so that means this value becomes 0. So if this value becomes 0, then there is multiplication sign, so you can put this to the right side, and at that time this number that becomes 0. Okay, so if this number becomes 0, so you can write this equation in that way: k1 and this one also written here, and this n1 is written to the right side. Okay, so now if n1 is 0, so you can write that k1 equals to this one, because n1 is 0. That means you can just push aside this into the right side. So k1 equals to alpha 1 2 and N2. From here you can write that N2 is equal to K1 by alpha 1 2. Okay, but when N2 is 0, so you can see that if N2 is 0, that means this whole number that becomes 0. In such a way, you can write that K1 equals to N1. Because N2 is 0 means this one, the value of this one is 0. So you can write that K1 equals to N1. So now if some values are there, then we can easily calculate the value of others. Okay. Then I have to rub this one. Okay. Now if dn to dt is equal to 0, that means R2 N2 K2 minus N2 minus alpha 2 1 N1 is equal to 0. Okay, now here you can write that if this one 0, so this is equal to 0, that means R2 is 0 and N2 is also 0. Okay, next you can write K2 minus N2 minus alpha 2 1 N1 is equal to 0. So when we can write alpha 2 minus, this is the N2, that means you can write here K2 minus alpha 2 1 N1, 2 for species 2, 1 for species 1. Okay, here also 1 for species 1, 2 for species 2, not 12 or 21, is equal to N2. Okay, now if N2 is 0, that means you can write K2 is equal to alpha 2 1 N1. So now you can write N1 equals to K2 by alpha 2 1. That means this K2 by alpha 2 1 equals to N1. Okay. Now if N1 is equal to 0, N1 is equal to 0, then what will happen? That means K2 minus alpha 2 1 N1 equals to N2. So if N1 is equal to 0, then you can write K2 equals to N2. Okay. So in such way, by solving the equation, we can get the actual outcomes. So there is a note. What is the note? Note is that, okay, so note is that first graph, the isocline intersects the graph x-axis, where this is the x-axis, where the carrying capacity K1. Okay, this graph intersect x-axis where the carrying capacity K1, and here the no species 2 present. Here the no species 2 present, and in the y-axis it intersects where K2 by alpha 1 2, when carrying capacity, that means K1, is filled by equivalent number of individual of species 2. Okay, it intersects on y-axis at a point where the species 2 is present but species 1 is absent here. Clear? So that means on x-axis K1 is present, carrying capacity is K1, that means here no species 2, but in the y-axis where it intersects, their value is K1 by alpha 1 2, that means here no species 1 present. Same thing is here, that is this line intersect on y-axis where the value or the carrying capacity is K2. K2 means there the species 2 present but species 1 absent. and it intersect on x-axis where the k2 by alpha 2 1 this point, and here which is present, there no species 2 present. Okay, here only species 1 present. Just species 1 graph and species 2 graph same, and simultaneously both the intersection and all things are same. Just you have to understand the points where the species 1 present or species 2 present, that is separately described here. So this is the actual graphical technique by which you can understand that LOTKA Volterra model. So another thing is there that some cases also I will try to describe in my next video. So continue with my channel, and thank you to all of you who have already subscribed my channel and support me a lot. Okay, thank you.